Hello from Melbourne, Australia. Firstly, I would like to acknowledge the traditional owners of the land of which I'm presenting and pay my respects to their elders, both past and present. My name's Marcus Ransom and I'm a Technical Delivery Manager for CompNow based out of Melbourne, Australia. I've been managing Apple devices for many years across education and enterprise, and I get a lot of satisfaction from helping people create amazing Apple environments. Some of you may recognise my voice from the Mac Admins podcast. I also help to organise the AUC's XWorld conference here in Australia, as well as Melbourne Apple Admins meetups. CompNow's been working with Jamf for many years. We're the first Jamf integrator in Australia before Jamf themselves had a presence, and now support a large part of the Apple market in the region across education, enterprise and government. We're also proud to have been selected to be Australia's first Apple authorised enterprise reseller, which is enabling many more enterprise partnerships with Jamf and Apple in our region. So what are we talking about today? We're going to look at the network connectivity that Apple devices need to operate properly and the challenges we can face achieving this in an enterprise or education environment. Essentially, it boils down to the fact that Apple devices need to access the internet. So why is this a problem? Well, generally it comes under the heading of security. Not every network is like the one you probably have at home, where you connect to the network and have essentially complete access to anything you request on the internet. Most workplaces or schools will have sophisticated tools in place to control what you can and can't access. This can often lead to issues with using and especially managing Apple devices. So we're going to talk about how we can ensure that we have everything running properly. We're going to break things down into 4 sections. What are the technical requirements so we know what we're aiming for? What are the sort of objections and challenges you're likely to face when trying to make sure everything is as it should be? What are some of the symptoms you may see on devices that will lead you to believe that things may not be configured properly? And what are some of the ways you can test the environment to try and pinpoint exactly where the issues lie? So we used to be able to manage Macs in a completely locked down environment. Manage via a binary and decide where everything was coming from. So this isn't the case anymore. MDM came and changed everything. You used to be able to avoid MDM if you didn't want to adhere to Apple's requirements. But as of High Sierra, this all changed. For the first time, there was functionality that could not be managed unless you were using MDM. To automatically run kernel extensions, you needed an MDM to approve them. And you'll never guess what heading this functionality came under. That's right, it's our old friend security. So how did we explain to our friendly colleagues over in the networking and security team what we need to do to get things working? That's right, we go straight to the documentation. Except for a long time, there really wasn't any. We had to use tools like Little Snitch or Wireshark to find out what all of the endpoints these chatty little computers were trying to access and then work out what it needed that access for. So the community stepped up and there were some awesome blogs out there listing all of the endpoints and collating what people had identified that they were needed for. So convincing network and security teams to open up whole sections of the internet based on the word of some random blog is tough. Speaking as someone who calls their blog ransomware, I know how hard it can be to point enterprise networking and security teams to a community blog and have it taken seriously. But fortunately it got a lot easier last year. Instead of having vague snippets of information dotted around the place, we got the famous Use Apple Products on Enterprise Networks. So what does this article tell us? It's awesome. It goes into very granular detail as to what endpoints Apple requires access to in order to function properly. It breaks them down into subgroups. It also provides important information as to whether the traffic from this endpoint in question can be proxied or not. So we can see what's required for device setup, device management, software updates, even the App Store. And in addition to the endpoints that Apple requires, as it's JNUC, and most of you will be using Jamf to manage your devices, we also need to ensure that we have access to some endpoints required by Jamf. So if you're running your servers on-prem, this is not going to be so much of an issue. If you're using Jamf Cloud, then we need to make sure that the devices can access your Jamf Cloud server, as well as the Jamf Cloud distribution point. So this is all pretty straightforward. We now have awesome documentation that tells us exactly what we need to ensure devices can access and what sort of requirements there are around proxies, SSL inspection, etc. Well, not so fast. Just because we know what we need doesn't mean that all the stakeholders are going to be on board. I spend a reasonable amount of time working with enterprise IT teams who are new to managing Apple devices, or at least new to managing them in a modern way. The objection usually revolves around their approach to security. So don't get me wrong, there are many organisations where for compliance reasons they have some pretty heavy-handed hoops to jump through. But you can also get organisations who impose these kind of restrictions on themselves without really needing to, or understanding the impact that they can have on someone's day-to-day use of their device. It would be great if they all had the wisdom of certain Supreme Court judges, but we can't have everything we want. Instead, we're going to see a lot of this, lots of big enterprise words thrown around that come from places all over the Gartner Magic Quadrant. In order to address these objections and to get the devices able to access all of the required resources in a functional manner, we need to work closely with these stakeholders and understand what their concerns are or what roadblocks we need to work together to eliminate. Maybe we channel another legal mind and remember what Atticus Finch told us. You never really understand a person until you consider things from their point of view. What are the reasons they don't want to allow these changes? What are the things they're worried about? How can we show them that they're going to make their life easier and their environment more secure when they implement these changes, rather than cause problems or expose risk? Most of the time, it's going to come down to our good friend security. So this is a common one. Just tell me the IP ranges you want open. It doesn't really work that way. It used to be that we could open up Apple's Class A 17/8, which was a tricky discussion in itself, but with considerable amounts of this traffic coming from the CDNs Apple use, 17/8 isn't enough anymore. The internet doesn't just run on static IP addresses these days. We need to ensure that whatever network security tools we're working with are able to manage traffic via fully qualified domain names. Sometimes we come across tools that are only able to manage traffic via IP address, which is ironic that the security tools are stuck in the dark age, as this is very much a legacy way of managing network access and isn't going to provide the degree of security that you need in a modern environment. So the reason we need a fully qualified domain name is because the hosts we're trying to reach are going to change dynamically. So if we run a query on one of the endpoints we need access to, say oscdn.apple.com, we can see that it's using canonical names in DNS to route the traffic to various different hosts to ensure we're getting fast distributed access. And if we only open up the IP address that we see here, there's no guarantee that it's going to work the next time we need to access that endpoint. Akamai will direct you to an IP address based on many factors: load, region, who knows what other reasons. It's their job to manage this, and they do it really well. And this is why large organizations like Apple use them. Here's the same result run from the USA. We can see totally different IP addresses. And the same thing when we go from the United Kingdom. So if your networking team tell you that their infrastructure isn't able to manage traffic by fully qualified domain name, that they can only use IP addresses, then you're going to have a lot of trouble getting the access you need. The network infrastructure is going to need to be updated to be more current. Now, this may be something that the network team's been wanting to do for some time, so your request might be what they need to tip things over to get the budget or resources allocated, especially if someone high up is wanting these Apple devices to be managed. If you want a great word that can be used to help push this business case along, try using security. This is another one. Now, we need to inspect all SSL traffic for security. Once again, this is going to break Apple management horribly. SSL Inspection is a buzzword used by a bunch of network security tools. You might hear it referenced as next generation firewalls, deep packet inspection. How it works is when a device requests something encrypted from the internet, the network tool decrypts the traffic so it can perform analysis, and then re-encrypts the traffic with a self-signed certificate that the devices are configured to trust. So the other term that can be used to describe this is a man-in-the-middle attack, and Apple devices are designed to prevent this on traffic from Apple. All Apple and Jamf traffic uses what's called certificate pinning to make sure that the traffic is only respected if it's encrypted with the original certificate. So it's going to fail hard if it's been inspected. Apple's documentation is quite clear about this. Our own network and security infrastructure is not going to be the best way to know if a BridgeOS update has been tampered with or if an enrollment profile hasn't come from our actual Jamf Pro instance. The vendors responsible for creating that content have all the right tools in place on our devices to ensure we're getting what we're asking for, all in the name of security. So there's a lot of mentioning of proxies in the documentation, especially where it's not supported. Organizations may say we need to proxy all traffic for security. So a proxy is a service that sits between a device and the internet, analyzing all requests and performing them on behalf of the device if they're identified as being permitted. If you want a great resource for looking at this, take a look at Dan McLaughlin's presentation here at JNUC last year. He's one of the smartest engineers I know, and he has had the poor misfortune of having to deal with some heavily proxied environments. So it used to be that this was pretty much a hard no for any Apple traffic, especially APNS. So things have come along quite considerably with Apple's support of proxies, even with APNS since 10.15.5. There is some traffic that's still not able to be proxied, so you're going to need to get bypass rules put in place for this. The challenges with proxies are going to be during enrollment. How do you set a proxy when you've yet to configure the device? So authenticated proxies are a real headache. Macs will quite often be in a situation where they're trying to access network resources when a user is not logged in. Think Mac OS updates and upgrades, especially if firmware is involved. Now, the reason Apple prevents proxying on these endpoints primarily comes down to security. There's a great deal of device-specific communication going on which requires it to be direct, and it's all coming from trusted sources. So that brings us to this one, which you'll get mainly in organizations that don't really support Apple devices. So these are crazy ideas, right? What kind of half-baked, not fit for the enterprise device management company would expect you to provide access to external hosts? So I especially love dealing with this objection at organizations extensively using Microsoft Office 365. We can then have a discussion about how they've implemented Microsoft's requirements for network access. Microsoft provides very clear, comprehensive documentation on what's required to allow their cloud-based tools to operate correctly. They've even got a list of URLs, even IP ranges where they're appropriate, and list what can be proxied and what can't be proxied. Sound familiar? They even go into some pretty specific language about how enterprise customers should review their network security and risk reduction methods specifically for Microsoft 365 bound traffic and use Microsoft 365 security features to reduce their reliance on intrusive, performance impacting and expensive network security technologies for Microsoft 365 network traffic. So using these explanations from Microsoft has been essential in helping to change opinions and show that you can allow traffic to flow without impacting on your security or negating the tools you've invested in. Microsoft talk about using technologies like proxies, SSL inspection, packet inspection, data loss prevention systems. These technologies provide important risk mitigation for generic internet requests, but can dramatically reduce performance, scalability, and the quality of end-user experience when applied to Microsoft 365 endpoints. The same goes for Apple. Apple is an enterprise organization with a deep, deep focus on security and privacy, and following their recommendations where we can, like we should for Microsoft, is going to do a lot to improve the security and end-user experiences we deliver. So now that we've got everything sorted out with our colleagues and we've agreed that they're going to provide the access we need, our work's done, right? Most of the time that is right, but not always. We may have issues with firewall rules being approved, but perhaps not being applied properly. I've experienced typos that took ages to identify, and I may have even been responsible for them myself. With larger teams, there may have been miscommunication between the people you've been negotiating with and the people actually implementing the rules, especially if the task's managed externally. You may also have issues due to Apple having changed something. The documentation has a section at the bottom where you can see when it was last modified. I'll get to a feature request about that later. So what sorts of things will we see that may lead us to feel that the network access is maybe not as it should be? So usually the first thing we're going to try and do is enroll and manage a device. This is going to give us a good indication if things are or maybe if they're not working properly. So Apple's quite specific as to the requirements we need here. We need to be able to enroll a device before we've done any configuration. So we're not able to set proxies or install certificates. The device is going to need to have clean access. Generally for the users, the only way they know that their device isn't enrolling is that they don't see the remote management screen at all and see this one. That could mean that the required Apple hosts aren't accessible on first boot, predominantly iprofiles.apple.com. Could also be thermal issues, but that's outside of the scope of what I'm discussing here, but I will put a link in later at the end about that one. Another issue we often come across is when Jamf Cloud isn't available to devices at the setup assistant. Either the firewall's blocking URL, or they require configuration or authentication before they can get out to external sites, which isn't going to work at the setup assistant before they've had the ability to configure that. So you might see this error that enrolling with a management server failed, or if you're using the new enrollment customization, you might see this instead of the Azure authentication screen. So Apple's documentation goes into a lot of specific detail as to what's required, both to set up a device and for the management to take place. You can see there's quite a lot of endpoints that devices need to access before anyone is actually logged in and ready to go. The end goal for a secure environment is to have our devices managed. So if we want to be able to manage devices and we need to open up these endpoints, we can talk about that being security, and that's why we need to open things up. So another one we see quite a lot is where App Store installs are failing. So devices can't launch the App Store on both Macs or iOS. Now this might be desired behavior, but if we want to restrict the App Store, that's best done with restrictions profile, not by blocking network access. Even MDM deployment of apps can be failing, or it's only failing some of the time if users have to authenticate to access all of the network. And the management logs are showing something like VPP redownload call timed out. So if you look at the list here for the App Store requirements, there's quite a few endpoints listed for App Store installs. Now many of these are rarely going to exist on Apple's 17/8 IP range. And this is where the list of endpoints is great. We see a lot of people opening up star.apple.com. Now that's great if you're able to do that. It saves going into that granular detail on all of these lists. But how much of this traffic isn't at an apple.com address? So the one that I've seen trip people up a lot is mzstatic.com. Because is that an Apple endpoint? Well, a quick whois will show us that it is indeed Apple, so we can safely and confidently open that up and give devices the access they need to be able to download apps from the App Store, which is a secure and simple method of getting apps that we know have been checked by Apple. Another one we see is we can boot to recovery. We can even boot to internet recovery. But when we try to install macOS, we keep getting errors, even if it's coming locally using a tool like MDS or Installer. It's a typically ambiguous error from Apple that the recovery server could not be contacted. But we checked all the internet recovery hosts. They're all open and working fine. Maybe we even just booted from them, so we know we can access them, but it's saying here we can't access the recovery server. So this is one that hit me before Apple produced the latest documentation. The only documentation we had in 2019 references devices needing to access some verisign.com endpoints, so I'd implemented this. But as the OS evolved, Apple included some additional certificate checking services. First, DigiCert came along, and then Entrust was added. The firewall and proxy rules in the environment I was working in didn't have these last two. And as a result, we weren't able to install Mojave on machines booted to recovery, internet or otherwise. So what's happening is Mojave is checking the validity of all of the certificates that we use for signing the installer to make sure they haven't been revoked. And if it wasn't able to check them, it just failed. So what would you describe the process of checking certificates to ensure they haven't been revoked? Security? If your security team don't want to open up access to these endpoints, ask them if they're happy having machines able to trust root certificates that have been revoked. Or maybe Hopper put it better in Stranger Things. So what are some of the tools we can look at to determine what's getting blocked and provide guidance on what needs to be remediated? So the command line's got some pretty good tools we can use, and we can also go down the deep rabbit hole of network analysis tools like Wireshark That's going to take a lot longer than I've got time for today, but there's also some great applications we can use to capture a big picture of everything that's going on specific to Apple and Jamf's requirements. These can also be useful if you're trying to get somebody else to run them remotely for you. They're also great at displaying visually what's working and what isn't. Now, some of the terminal commands I use to quickly check network access are these ones you can see here. dig or NSLOOKUP for DNS resolution. Now, using multiple tools to check the same thing can be quite useful, especially when you're dealing with edge cases or unexpected results. An example of this is using both NC and NSCurl to try and access endpoints. NSCurl's got much better proxy awareness, and that could show you why certain parts of the operating system can access an endpoint when there's a proxy at play, but others can't due to how they respect the system proxies. Checking certificates with OpenSSL to make sure there's no inspection going on. Try all of these tethered to your phone and then from the network to see if it's reporting the same on both networks, if you're getting different results. Doing this relies on running a whole lot of commands to check everything in Apple's documentation. There's quite a lot of endpoints in there. So there's some better ways of doing this. Push diagnostics, for example, is available on the Mac App Store from Two Canoes. And that's got a really simple interface. It started out originally just checking for APNS communications, but in the way he likes to do, Tim Perfett has of course added awesome functionality to be able to check all of the endpoints in Apple's documentation. You just click start and away it goes. You get nice red entries for places where we have a problem. So this one here is an example from an enterprise customer network I was preparing to be able to support MDM, and you can see they've got quite a few challenges we need to address. But it's great because we've now got a good reference point, and we can even output the log file to create a report for the teams that need to remediate without having to cut and paste text or try and copy it manually and get a typo. Mac Eval Utility, that's a tool created by Apple engineers for performing the same kind of lookups, in addition to checking some of the other configurations of your machines, such as KEX, 32-bit apps, and a bunch of other things that are helpful to identify an organization's readiness for modern Apple deployments. It's not publicly available, but have a chat to your friendly Apple SE, and they can hopefully point you in the right direction. So the new kid on the block is Jamf's own Jamf Environment Test. You might recognize the main contributor, Daniel McLaughlin, from the Proxy video I mentioned before. Jamf Environment Test allows you to run all the tests against Apple's required endpoints, in addition to Jamf's specific endpoints, and it also does some system checks. It's available on GitHub and the Jamf Marketplace, so it's really easy to get hold of or to direct someone else to if you need them to run it on your behalf. Download the app, open it, click to start running, and at the end you get a nice HTML output that you can save or share with whoever needs to see the results. The GitHub repo also has the raw shell script that's running in the background. Now this way you can provide network engineers the commands that it's running. You can run them manually or correlate them to commands they can run from whatever devices they're using if you need to drill down on a particular endpoint you're having issues with, or to explain to them what the checks actually are that are showing that it's failing, to give them confidence that they're going to be able to resolve these issues and where the problem might be. So awesome work, Dan and Jamf, on this tool. Using a combination of these tools is hopefully going to help you identify where things are not configured the way they should be, and to be able to communicate this to the people who are able to make the required changes to get things fixed. Some of the things I would love to see Apple provide as an improvement for the enterprise networking documentation is a changelog, so you can see what's been updated and when it was updated. And that might explain why when you've put all of this work in implementing the rules and suddenly a couple of things stop working. At the moment, the only indication we have is that the date at the bottom of the KBase article changing, with nothing to tell us what the actual changes were. It'd also be great to be able to get notifications when changes have been made. Microsoft actually give us 30 days warning before any changes are made to the IP ranges or URLs in their documentation. They also provide an API so that you can use that to automate the updating of your network infrastructure. In addition to this, Microsoft have a list of networking partners, vendors such as Zscaler and Citrix, who've demonstrated that they understand the requirements of Microsoft's network access, and their documentation reflects this. They often have simple built-in one-click configurations to apply the correct settings. It would be fantastic to see Apple helping vendors such as Zscaler, Cisco, HP, Meraki, Palo Alto provide clear documentation using technical language understood by networking engineers to make it easier for us to provide Apple environments. I know Apple works behind the scenes with all of these organizations, but sometimes having a logo prominently visible by an engineer working in an environment gives them trust that this is actually what they should be doing. So let's look back at what we've discussed. Apple have got some pretty specific requirements. Read as much as you can so you understand what's required. Implementing this is often going to require assistance from networking and security teams, so do everything you can to have a good working relationship with them. Understand what their objections are and what motivates them to configure things the way they do. What are the risks they're trying to protect their users from? Test and verify that everything is working, especially with betas, before they go into production. And stop blocking traffic unless you really need to. Now here's some of the links to the items I've referenced in this presentation. They're all available on my blog, and I'll also link to this video and slides when they're available. If you have any questions after JNUC, please feel free to get in touch via the Mac Admin's Slack. I'd love to hear how you have overcome these challenges in your environment and anything you discovered along the way. Thank you for listening. I look forward to hopefully seeing you all again at JNUC next year.